Today, we'll discuss how to speed up your large Go test suite by breaking it apart and running each piece in parallel. So, we all know that CI, continuous integration test results, are critical for maintaining good developer velocity. If your test suite is quick, you get immediate feedback regarding whether something broke, and it's generally a more enjoyable development process when you get faster feedback. And of course, if you have critical bug fixes and changes that you need to push to production, having a faster test suite is also helpful. Previously, we covered how to accurately measure the execution time of Go tests, and I'll put that link in the description. Here, we'll talk about how to break apart a large Go test suite. So let's jump into some basics. So the standard way to run all Go tests is Go test, and then basically you specify all the packages and you go ahead and run this. So this command will compile each of the Go packages and their tests into a separate binary, and then it will kick off those binaries in parallel. And this can be controlled with the -p flag to specify how many things you want to run in parallel. But it'll default to the number of CPUs on your machine, so generally you don't need to specify that flag. So when we're talking about splitting up the test suite, this only makes sense if you have a lot of packages to tests. If you have very few packages, or if you have like 1 or 2 packages that just dominate your test time, that take, I don't know, 80% of your test time, then this simple split that we're going to talk about may not help much. You may need to refactor your code, or even run some tests in one job of the same package and other tests in another job of the same package. We're not going to focus on that here because it's somewhat an inefficient approach, but I do say that currently we are using that approach. All right, let's go ahead and talk about how to find all the packages in your project. So this runs all the packages, but what if you want to know what your packages are? So there's a go list command, go list. And I'll actually run this one, and it'll list all the packages in your project. So, we have quite a few, and most of them have tests. And then what we want to do is we can just split them, of course, just, course split them. Or we can also do some additional analysis and identify which ones are slow. So you can run your test suite. If you run your test suite and you pass in the -JSON flag, it will output the test results in a JSON format that kind of looks like this. So I ran a subset of the test suite, kind of looks like this. And the thing we're looking for is the elapsed time for each package. So if you just search for elapsed, let's find some numbers. Here we go. So we're looking for lines like this. So we're looking for a package with an elapsed time. So we have this file. So we can use kind of JQ, which is parses JSON format to get all these elapsed times and sort them. So let's actually go ahead and do that. So let's do cat go test JSON, which is this file, and then we'll pass it to JQ. We'll run a command. So we're going to group by.package, package is right here. And we're going to pipe it to a map. And in that map, we want the package and we want the elapsed time. So I might make a syntax error here, but hopefully, so package is always, it's going to be the first index, package, elapsed, don't want to misspell it. elapse, test. We actually, there's some fine tuning here, but we'll do a coarse approach. I think we just want this number down here. We want to make sure we exclude these elapsed times. Okay, so the key I realized is that we need to filter these out. So we can filter these test-specific results up front because all we want is the package-specific result here. So we can do that in the beginning by map select has test. Oops. And what we want is not to have it, right? So test has test not. And let's see, right number of parentheses looks good. Okay. So we get all the lines that don't have test. We group them by package, which creates a bunch of arrays. Then we map those arrays. We keep the package name, and for the elapsed one, we basically need the elapsed time, which there should be only one at this point. But we'll just use a map just in case. Okay, this is our map. And then we're gonna sort them. Sort by elapsed. Let's see, this should give us something. Let's go ahead and run this. Yep. We can also reverse the sort with the pipe reverse command. But I just did this so I can see the packages that take up the most time on the bottom, right? So we will have the ones that take up the most time. So you can look at these numbers and reorganize. Now, we did do a previous video on determining test times. So there may be some things going on that make these numbers not look exactly the same because several things are running in parallel. So at the time when this package runs, the CPU may be loaded with other stuff running parallel. So it's the time for this may be faster if it's running on its own. However, other packages may not be parallelizable and they may be running by themselves on your whole CPU. So you got to keep in mind that these numbers are just estimates and not exactly correct. All right, so now at this point, looking at all your packages, looking at how much they take, you should be able to figure out how to group these in separate groups. So once you group them, then you can run the group by simply going go test. Suppose I want all my fleet control packages in one test, and in addition to that, I want my server service package there as well. So suppose this is one group, and this is how you would run that single group. Now the question comes up, what if I don't put packages in a group? How do I make sure that I'm still running all my tests and I'm not missing something, right? And for that, we can use the Linux com command. It compares two sorted things, files, or you can pipe them in line by line. And we just want to get everything that's in our kind of default package list that's not included in our other package lists. So let's go ahead and show an example of this. Oops. Right here. Okay. So let's try to use the com command here. So com, and reference here we can have we can have 3 columns here, but we're only interested in files unique, in things that are going to be unique to the first one. Com -23 to exclude the second and third column, and then we're going to give it all our packages here, and we need to sort them. I think by default the list is sorted, but this is here there just in case. And then we compare it with all our groups. So this could get long, but it looks like this. So suppose one of my groups was like this. Control CTL, okay, dash, and then I can add additional packages here. And suppose, I can add additional ones here. And then my another group included server service packages and maybe other ones, etc., etc. I'm going to do a semicolon. So this runs as its own in its own subshell, and I will sort this. So we have two sorted lists, and we're just going to get everything that's in the first list that's not included in the second list. So let's go ahead and see. We'll run this. Okay, we can look at our list quite a while. Let's scroll up. So I do not want to see CMD fleet control, and you see I do not have CMD fleet control. I also don't want to see server service, server MS, and that's not there either, right? So there's a way to get just a default list that excludes all other ones. So let's take a look at the actual code. So in our project, we're doing something like this. So we define kind of our default list. We want to pull in all the Go tests from these directories. And then we define kind of our specific list. So here's like a fast list for fast packages, fleet control list, MySQL list, and a few other ones. And then we're naming them. So here are the names. So this is the key variable that's passed into this makefile, and this main list is kind of the default list. Here's where we run that com command. Is we compare the default list to all our other lists, and then we have the other lists: fast list, fleet control list, MySQL script service, etc. So this way we set this CI packages to test that contains the specific packages we want to test. All right, so the last thing to talk about is creating an actual parallel jobs using your CI tools. So the major CI tools provide a way to start multiple jobs in parallel. So in GitHub specifically, this is done with a matrix strategy. So let's go ahead and take a look at the quick docs. You can just search for GitHub matrix strategy. And this is how it looks: strategy matrix, and then it'll run the job across all the versions and across all the OSs in this example, right? So we're going to use the same kind of approach, but for our suites, which we saw here. So we define them in this makefile, and we're going to pass them from our matrix strategy to this makefile. So let's actually go ahead and take a look at what our suite looks like. So this is production grade, so it has a little more detail here about stuff that it's doing. So we have strategy matrix, and here's where we define some suites. So you notice we do have some additional items here, and I'll mention why those exist here, but these over here are just mapped directly to what we had in our makefile. So we run across the suites, we run across MySQL versions, we do some exclusions here because not all the suites require MySQL, so we exclude extra runs because they're not needed. And there we do some additional work to customize what we actually run, because some suites need certain out-of-process dependencies. For example, some suites need Docker, some suites need ZSH down here. So we can actually optimize our test suites. Okay, so the ones that I mentioned that were not in the file, these integration core, integration-test suites. So this is an example where we're actually taking one package because it takes so long to run and we're breaking it apart. So as I mentioned before, this is not a great practice. Our plan is to refactor this into their own packages. But let's take a look at an example here. So integration core, we take this service package, which is defined in our makefile. Service down here, service packages to test, just maps to this one service package. So we're taking it and we're saying we're gonna run all tests that start with test integrations, but skip all the ones that start with test integration MDM or test integration enterprise. And then we have integration MDM, which is also service, which says run everything starting with test integration MDM, and then integrations enterprise, run everything. So we're basically effectively taking this one package, one service package, and splitting it across 4 jobs. We have a service jobs that runs everything that's non-skip, -skip, that's not test integration. And then we have 3 integration jobs. So as I mentioned, our plan is to kind of refactor these integrations into their own packages. So that way we can take advantage of the parallelism that's provided by Go, where you can run packages in parallel. That's our plan going forward. All right, so let's take a look at how this looks like once we actually run it. So we can go and look at a run. So we have a bunch of stuff running. We also had like another test that we're running in a completely separate job. But if we look at this matrix, we see everything that was been running and how long it took. And then, next thing we want to do is we kind of want to look at the outliers and make sure we, push the outliers down. All right, that's it for today. I hope you found it useful.